Can you believe it? There's a technology that can fuse different materials together without any adhesives. Whether it's the same metal, different metals, metal and ceramic, or metal and non-metal, it achieves an atomic level bond, forming a seamless, solid piece. This is vacuum diffusion welding technology. Precision align the workpieces using specialized fixtures and place them into the vacuum diffusion welding equipment, pumping the furnace chamber to high vacuum to prevent high temperature oxidation and facilitate diffusion. The diffusion welding process temperature is generally set at 0.5 to 0.8 times the base material's melting point, with corresponding pressure applied simultaneously. Under the combined action of temperature and pressure, microscopic plastic deformation occurs at the contact interface, achieving atomic level close contact. Subsequently, atoms continuously diffuse across the interface, ultimately achieving solid-state metallurgical bonding. After completion, the workpiece is slowly cooled, depressurized, and removed. The diffusion welding process requires precise control of the heating rate, holding temperature, pressure values, and accurate loading, as well as precise displacement of the pressure head to apply the controlled pressure, in order to achieve high-quality welded components. Vacuum diffusion welding technology is primarily applied in high-end manufacturing fields such as aerospace engine blades, missile control surfaces, microchannel heat exchangers, nuclear power components, and semiconductor ambassador material chip packaging. Next, let's take a look at the mainstream vacuum diffusion welding equipment available on the market. Follow ACME to learn more about advanced vacuum heat treatment equipment.